We'll get started shortly here, everyone. I see folks coming into the meeting. Okay, it looks like that's settling down. So I'm going to start. Welcome to the C3.ai Digital Transformation Institute Computing Environment Orientation C3AI Suite Deep Dive. This is one of a short series of webinars that we're doing to support our call for proposals. For today, we're going to start with a brief review of the previous computing webinar, and then we're going to spend the bulk of our time presenting on the C3, what we call a C3 deep dive, presented through the integrated development studio of the platform, and we'll go into the topics shown on the screen. We're also going to take a timeout after that to review what constitutes required use of the C3 AI technology. So as we go through the C3 deep dive today, you may, if you're considering a submission in response to our call for proposals, you may want to consider your own technology landscape for your research as it is now, and think about how you might leverage some of these C3 AI technologies to help facilitate that work and to also make it part of your work plan for your proposal. We'll talk about some follow-on sessions we'll be having, and we intend to leave a fair amount of time for question and answer. In our previous webinar, we introduced the DTI DevOps staff. That includes folks like myself at UC Berkeley and our colleagues at the University of Illinois Urbana-Champaign and CSA. And among us, we have many years of experience supporting research with computing. And we continue to do that for DTI awardees. We also discussed in our last webinar how a new feature in this call for proposals is that if you like, you can consider, in a sense, inviting one of us to join your research team in a more formal way to actually dedicate a portion of our time to your work plan in your proposal. And this would be complementary to the award you would get. This wouldn't come out of the award funding. We also, in our previous webinar, gave an overview of the full set of computational resources available to awardees, including the C3 AI technologies that we'll get into more deeply today and in our follow-on webinar. We talked about the high performance computing that's available at NERSC and NCSA, as well as Microsoft Azure. And as we do these webinars, we are posting them to our YouTube channel via the link at the bottom. And there's a delay of a couple of days, typically between the presentation and availability. I'd like to now hand over the presentation to a colleague of mine, Armand, who is an engineer who works at C3AI, and he is going to take us through this deep dive. So I am going to stop my screen share and invite Armand to pick up the screen share.
All right. Hi, everyone. I guess, first of all, you should be able to see my screen. But yeah, my name's Armand Butt, and I'm a solutions engineer at C3. And for today's presentation, it's building off of the previous webinar where we introduced at a high level some of the C3AI tooling that'll be made available to the researchers as this round of call for proposals. So today, I'm going to be actually drilling into all of the features a lot more deeper than before that are available as part of the C3AI suite. What you won't find in this presentation today is actually a deep dive of our no-code ML product, Ex Machina. That'll be in next week's webinar. Today's webinar is really about our core platform features. So to start off, I always love to show this slide, and it's really the challenge in building ML applications and actually doing ML development. And it's really that the algorithm or the machine learning model is less than 5% of the code. And what you find is that in order to do your machine learning development and analysis, training your models, there's actually a lot of other code that even researchers need to be involved with to write. This can be related to data collection and unifying your data across many different sources. It could involve different analysis tools, actually having server infrastructure to be able to make sure that all of your tooling is up all the time, and even some monitoring of what's going on And what we found is that, for you as a researcher, you want to focus on actually doing what provides the most value, which is actually developing the machine learning models, developing those machine learning applications. So at C3, what we've done is that we actually have built a suite that's made to actually accelerate what we call these multiple phases as part of the enterprise AI lifecycle. So we have a bunch of tooling that's been made available on our platform that ranges from data engineering all the way through machine learning engineering and development, and then even application development on top of all that work that you would have done as part of the previous steps. And our platform is really the center in terms of being able to not only unify all of the different toolings that are required as part of this process, but also to make sure that all of the different stakeholders that are involved in this development are able to access it in a unified way. So the central tenet to our platform is this idea of the model-driven architecture. So in this case, a model isn't referring to a machine learning model, but in terms of the traditional sense of a simplified representation of something that's real or more complex. Over here on the slide, I have examples of a few data stores. So on the left, I have examples of key value data stores, right? They each have maybe their own language to interface. They have their own infrastructure to deal with. But to the platform, these are just key value stores, nothing more than that. In the basic sense, they're just key value stores. On the right, I have a bunch of relational databases that each have their own potential SQL language with their own nuances. But again, to the platform, these are just relational databases. So the idea is that models make data and processing easier to understand and work with, as well as instead of you as a user having to interact necessarily with a particular data store, if we're able to abstract these higher level models, you can focus on interacting with those as opposed to those underlying technologies. So it's really to focus on the what and not the how. So if you want to store time series data in a key value store and then keep the labels in the relational databases, you'll only be dealing with the relational database as well as the key value store, as opposed to dealing with the underlying, for example, PostgreSQL or Cassandra queries that you need to make. And likewise, if you want to move some of your data over to cloud storage or to even interact with data in cloud storage, you would deal with a cloud storage object model as opposed to the underlying data store, which could be from AWS's S3 buckets or even Azure Blob Store. So over here, I have an example of what the difference is between kind of your more traditional structured programming approach versus a model-driven architecture approach. So if I want to maybe query some data in Oracle, if I want to select some books, I would be writing a SQL select with, select from books where. If I want to upsert some data into Cassandra, that will require its own syntax. And maybe if I wanted to interact with the underlying, infrastructure technology, that'd be in its own language as well and its own way to interact with it. So it's 3 different skill sets and also in 3 different places. However, with a model-driven architecture in the C3 platform, this uses a common API amongst all of these data sources. So instead of doing a select in a particular language for a database, I can do a fetch on a book object, and that book object can actually have data across a variety of data sources. However, the API and the way you interact with it is just a fetch. Likewise, if I want to upsert data, I would just be doing like a movies.upsert. And we also have a bunch of APIs related to the underlying infrastructure management as well that are in the similar vein as everything else. So you can see, as opposed to 3 different skill sets, it's only 1. As well as via the platform, they're actually all located within the same unified interface as well. So the way this has actually been implemented on the platform is through this idea of types. And these types are actually, everything in C3 is a type. So they could represent logical objects, objects that reside in data stores. They can also represent machine learning pipelines and machine learning models as well, and even UI. They're very similar to Java classes, and they can contain different fields, primitives, collections, as well as even methods to implement your different business logic that you might have. Likewise, unlike your traditional classes that you have in other languages, the C3 platform is actually language agnostic. So you can actually implement your functions and methods in Python, JavaScript, or R, and actually call between those different languages and runtimes the same methods, and it would be able to do the translation amongst them, which is really powerful. And the reason why this is so important is because, like, we know that researchers come from a variety of backgrounds. So some researchers obviously have a very traditional type of software engineering background where they would be very comfortable in IDE or Vim, and they can just code traditionally. But likewise, you have other researchers that might be, maybe just used to the Jupyter notebooks and maybe just comfortable in the Jupyter interface. And some researchers that might not have any of those skill sets and would like to interface with the tooling in a no-code way. And what the platform has allowed us to do is that by creating this unified interface across all of these different types, regardless of how you feel comfortable with interacting and what your skill set is, there is a way for you to interact with the platform and the underlying data that you have and do powerful machine learning, regardless of your skill set that you may have with regards to programming. So the way we interact with the platform, it's typically through a web browser, but we also support coding in a traditional sense through Eclipse or even Visual Studio Code, of which we do have a public plugin available. And over here is a example of our integrated development studio. So this houses all the different toolings that are available on the platform via a web interface. So again, if you don't want to deal with IDE or anything that looks like Java, no need to worry. You can log into a web browser, go to your application, and then start building types to represent your different data sources that you might have. And likewise, your types can actually connect to external data sources as well, which I'll be going into in our next section. So as part of that AI lifecycle, the first thing you need to do is get your data, do some processing, and be able to get it into one place. And the way we do this on the platform is through a canonical integration model. So a canonical is a type, and it's a type that actually represents the schema of your raw data, exactly one-to-one of what you have available there. And by specifying your canonical and then even these transform types that actually can transform your canonical data onto your main types that you might define on the platform, you're then able to, in a low-code way, be able to map different data sources to all of your actual new types that you have created as part of your data model. So the cool thing about the canonicals is that they actually don't care what your underlying data is or where your raw data is. It could be CSVs, it could be in Postgres, it can be an Azure Data Lake, it could be on an SFTP server, it could be a streaming source. The canonical only cares about what data should I expect. And by being able to do this, you can actually consolidate data across a variety of data sources you may have, and then after be able to build out any transforms or expressions that you might need to do as part of the data processing to then consolidate the data within the platform. So this is how it actually looks if you were to use traditional IDE. On the left, you have the canonicals, and you can see I'm trying to define fields that I expect as part of this canonical smart bulb data source. And on the right, you can see a transform where I'm actually specifying an expression and trying to do some manipulation to then map it to data sources we have on the platform. So we support a whole slew of data integrations. Wherever your data is, in whatever format it is, we can ingest it onto the platform. And the way you do it is in that simple canonical transform format, which is extraordinarily powerful. It automatically is able to break up data into smaller chunks and to handle the loading over time. So you don't have to worry about if your file is too large, that it will be too large to process. The platform is actually highly scalable and distributed. So it's able to automatically do the necessary chunking to be able to pull in your data onto the platform. And again, on your side, you're only telling it, hey, this is the data I have. Here's I want to transform it. Here's where I want to keep it. You're not actually handling what would be a traditional infrastructure ETL configurations that normally would go with these type of data pipelines. So obviously having your data in a consolidated image is really helpful. But the thing is that you can maybe lose track of where did your data originally come from when you're trying to investigate maybe some data quality issues. Likewise, once you start consolidating your data across your different sources and bringing them into the platform, you definitely want to check, is the quality of the data good, and is it able to match the raw data, or is it actually the raw data that might have the issue? So as part of the platform, we actually maintain data lineage as well as data quality as part of our data ingestion process. So through our integrated development studio, IDS, we can actually trace where did this data come from, and you'd be able to see, as you can see near the bottom of the slide, the different mappings of where that data had to traverse through before it landed in a final type. So this is really powerful because you can actually see per record where did that data originally come from and from what data source. Likewise, you can also profile your data. So the platform supports a whole slew of features of being able to check different columns and entities that you might have ingested, and to be able to see, what's the min value, max value, the distribution, the standard deviation. And it can even help identify fields that might actually have a high cardinality. That is to say that these would be good fields for to use as identifiers. So this is really powerful, especially in the data exploration phase that your research team might find yourselves in, where if you can actually pull in your data into the platform, you'd be able to start piecing together even foreign keys amongst different data sets, as well as to really profile the data and start to understand what you have available, which is helpful, especially if you have an extraordinarily large data set. It can be difficult using, your traditional like Python and, Jupyter notebooks on your local machine versus with the platform. It has the scalability to actually profile large sets of data and to provide those results in a basic UI. So going into the next platform topic is what I find one of the most powerful features of the platform, and really one of the more unique ones, and it has to deal with time series data. So by time series data, exactly as the name implies, you have a whole bunch of records that have some type of value. Maybe they have units, they come in a certain frequency, and they have some type of timestamp width. So these are very common in terms of to be used in machine learning models, and a lot of time series data is actually used as part of your feature engineering, as well as features within your machine learning models. And kind of the common challenges with dealing with time series data are that they could, maybe each of the different points have different units of measure. The date stamps can be in different formats. There's also different time zones. Depending on the source of the data, if it's like a sensor data, you might end up with duplicates or overlaps, as well as if it's from a streaming source, for example, you might receive the data out of order. So these are all common problems that a lot of researchers have. And the thing is, when you're working as a team, you can definitely code out and spend a lot of time, building up like functions to actually handle this. But depending on the way you implemented it, it might not provide consistent results. So the problem that I've seen with a lot of researchers is that even though you're dealing with the same data, if the way you've actually processed the data is not consistent, one researcher, even though they're training with the same data, they're not getting the same view of data. So this could skew your results a lot. So as part of the platform, we've built this normalization engine, which in low code can actually represent the different processing that you would normally do with regards to being able to handle and wrangle with these time series data. And this normalization can actually be done as a pre-processing. So as your data is coming into the platform, or also at runtime. So you can keep your raw data in the same format as you have it. And then the platform, upon execution, can actually then do the cleaning and normalize your time series data. So in the platform, we call this time series data, or the representation of your time series data, metrics. And metrics are defined in basically either a JSON config or even the UI. And it's a low code expression way of being able to describe the manipulations of your data. And then once you have created your metric and specified whatever logic you'd want to occur on the data, you can actually evaluate your time series in Python, JavaScript, R, or even a REST API to maybe another client. So once you've defined your metric, the actual logic is agnostic of any language and can be accessed in a whole slew of different ways. Including even in our Ex Machina product as well. And metrics are also composable. So you can build simple metrics that match against your raw data, but then you can also build what we call these compound metrics, which could then build on simple metrics, as well as build across different compound metrics and to build on really complicated logic. So these time series data, you can do an immense amount of representation in very low code that represents very complex manipulations, which otherwise in a traditional structured programming approach could be hundreds to maybe even like a few thousand lines of code. And likewise, we actually do support an integrated development studio, a GUI on the web browser to be able to develop as well as debug your metrics and to be able to see those manipulations in real time. And again, this doesn't impact the raw data, so your raw data stays the same, but by building your metrics, it can then run those manipulations in real time and then cache them. So then you have your clean normalized data in a constant view across the different ways you're interacting with your data. So now going into one of the, what obviously all you researchers are involved with, the machine learning and data science on the C3DTI suite. So once you actually have your data all processed, cleaned up, available in a unified data store, it's time to get to the real work, which is being able to come up with insights from your data and train powerful machine learning models. So the way this is done on the platform is using ML pipelines. So ML pipelines, very similar to the other things I described, they're low-code declarative and composable pipes that can then be connected together to describe complex training pipelines as part of your machine learning development. And similar to metrics, these ML pipelines are language agnostic. So you can build them in JavaScript, Python, or R, and then be able to run them from any environment as well. And the way we've been able to do this is we were able to take all the most popular libraries for machine learning that you know and love, and then to be able to encapsulate them into this ML pipeline framework. So under the hood of these ML pipelines, they're running in their native environment, whether Python or R. But by encapsulating them into the ML pipeline, they're now language agnostic. So they have common inputs and outputs that you can then hook together very easily in a few lines of code, and then be able to run and train them in a similar fashion, regardless of the library you may have. And we've built a whole bunch of pre-built ML pipelines based on the common libraries used by data scientists, but also within the framework we can actually allow researchers to build your own ML pipeline. So maybe you have your own custom library, or maybe there's a ML library that we've not built a pipeline for. It's very easy for us to be able to build the ML pipelines as part of the platform. And likewise, we support a whole source of repositories, even custom repositories, where you'd be able to pull in that library onto the platform and then encapsulate it into an ML pipeline. So over here is an example of a OCR and deep learning pipeline. And you can see here the use cases to be able to classify the sentiment of tweets extracted from a whole bunch of documents. So in ML pipelines, it's a very composable way to be able to build this out, where we are first able to extract, the images from PDFs, then apply the Google Tesseract OCR library to be able to then pull out the text, do some little bit of cleanup and tokenization, and then we're able to actually pass it into a sentiment classifier, which is a neural network running in TensorFlow, and then have our outputs. So by using these ML pipelines, you can see that you can use a variety of different libraries without worrying about the nuances that come with those libraries, and having that unified API across all of them to be able to quickly build it and train across it in a simple way. And by using ML pipelines, even though it might seem too good to be true, or maybe abstracting away too much, it definitely isn't the case. The ML pipelines support a whole variety of use cases and complex use cases. One of which here is even being able to do transfer of learning between deep learning models, which is extraordinarily powerful. And likewise, ML pipelines can actually support pre-trained models. So if you actually have a trained model from Keras or PyTorch or scikit-learn that you'd want to have in an ML pipeline, you can actually import it and then get all the great features that come with having your model in an ML pipeline. And yeah, over here you can see from the slide, we have an example of being able to take our features or our metrics that we've developed and put them in a logistic regression pipeline, and then even set a hyperparameter as part of the sklearn pipeline. And to train it, it's in one line of code, and then you can just pull your results into a pandas data frame or even JSON object. And this is all done actually through our C3DTI Jupyter service. But you can see that the ML pipelines are extraordinarily low code and can really accelerate your machine learning development that you'll be doing. So diving into one of the ways that you'll be interfacing with the platform to do your machine learning, it's through this application that we have as part of IDS called ML Studio. And ML Studio is kind of your main landing page as a data scientist, where you'd be able to prototype, deploy, scale, and even monitor and see the results of your ML training, all through a beautiful web interface that's available. And we also have a whole bunch of Jupyter notebooks that can be accessed through ML Studio. And we have a whole bunch of experiments that are pre-built just to show how to do common machine learning development through our ML pipelines framework, as well as ML Studio. We also support on ML Studio the ability to do AutoML. So we have, for a set number of libraries, the ability to do auto hyperparameter optimization. So this is extraordinarily powerful because it can really accelerate the development of your research. We've been able to do it to a few libraries, and the list is growing every day. But this is all available through ML Studio. And likewise, as you start building your machine learning models and have a whole bunch of them, you can very easily interact with each of your trained models, see their accuracy metrics like precision and recall, and to actually see like how has your model improved over time. Also, as part of the ML pipelines framework, we actually keep the metadata related to the training of the model. So for example, you'll be able to exactly see who was the one that did the training, what was the data that they actually trained on, what was the library that was trained on, as well as like see the results. So by doing that, you can actually drill into and see as you do your feature engineering, track how the changes in your features and data have impacted your machine learning models, and likewise even see how the hyperparameters and their tuning have impacted the models over time as we keep each of those trainings sets as a record as part of the ML pipeline framework. And of course, data scientists, where would you be without Jupyter? So we support Jupyter and we actually have it via a self-service portal through IDS. As a data scientist, rather than relying on IT to go in and make the environment the exact way that you'd want it, we support through the UI interface the ability to be able to spin up new Jupyter instances where you can actually configure the number of cores as well as the RAM, as well as if you want GPU enabled on the service, as well as actually being able to configure the runtime and libraries you want available within the Jupyter kernel. So if there's any version of a particular library that you're using and you need that specific version, by using the C3DTI suite, you don't have to worry about that. You can easily configure the versioning as well as the Python language versioning, as well as even if you are doing your development in R, this can all be configured in IDS and spin up a Jupyter instance tailored to your needs. And after all that hard work that you would have done, it might be time to actually deploy or productionize your ML model. And with the platform, you can actually deploy your ML models in one click. And that's one of the features as part of the ML pipelines framework. So once you do have a ML model that is the champion amongst everything else, you can one click to productionize it, and it will be available to be put into an application, as well as available to outside clients as well. So it can be made available via a REST API. So if you have a use case where maybe you want to build a application in a web browser, or maybe have like an Android or iPhone app that sends data and wants to get predictions from your ML model, it's a one click to productionize once you have the model trained, and it's available via REST interface to any of these other devices. And likewise on the platform, we actually have a UI designer, which is a no-code component library based on React. So once you've done all of this work, and on top of productionizing your ML model, if you actually want to build a dashboard to show the different data and results that you may have, or even a full-fledged application entirely built on the platform, you can do this in IDS in a low-code way. And everything that's a type can be made available to all the components. So whether it's your data that you've brought into your platform, or external data sources, or even your machine learning models that you may have, this can all be made accessible to UI Designer, and you can build extraordinarily powerful dashboards with different chartings, maps, data tables, and all of that, all available within the application. And again, this can be made publicly available in the sense that this can be put onto the open web. So this can be accessed even by external users to the platform. And that brings me to the last point, where one of the questions I get asked is, like, once I've done all this work on the platform, how can I access it through all these other tools I may have? And our platform is open and extensible. And one of the ways it's open is that all of the types are actually REST enabled. So any of the types you build, whether they're data types or machine learning pipelines, all of the methods that are actually defined on those types, whether it's retrieving data, starting to train the model, see what the accuracy metrics are, getting time series data that is normalized and cleaned, all of this is available via a REST API as part of the platform. So it can be made accessible via token-based authentication. And we also have role-based access control in case you don't want like external users to have access to certain APIs. But this is using an open web format, JSON post, payloads, and all of that stuff. So once you've built all of these things on the platform, they can be easily accessed outside of the platform as well. So this is extraordinarily powerful and hopefully can help with some of the use cases that you may have. And yeah, with that, that is all the slides I have. So thank you for listening to my part of the presentation. Hopefully this was helpful in giving you a high level and deep overview of the platform. And now I'll be passing it back to Greg to continue the main presentation.
Thank you, Armand. Let me move over to my presentation. So you've now seen what we call our deep dive into C3 AI suite. And we did this to help folks begin to understand how the platform works and what services are available. We're doing this because your proposals will need to address specifically how you would intend to use the C3 AI technologies as part of the work plan for your project. And I want to give some examples of that, how that might look for you. No two proposals would be exactly the same. You may want to use the data tooling in the platform for things like exploration, ingesting the data and processing it. In the suite itself, there's scalable data processing, the ability to handle multiple data sources, and dynamically updated data, time series data. Armand talked about a lot of these things. At a follow-on webinar, we're going to talk about the C3 Ex Machina tool and its data tooling, among other features. And if you're accustomed to using Jupyter notebooks, you can use the platform's built-in notebooks to work with your data. For your machine learning apps, the platform can help with development, deployment, and monitoring of those apps, ML pipelines, ML ops, and the C3 AI Ex Machina, again, which we'll talk about on our follow-on webinar, gives you the opportunity to do no-code machine learning. And you can see over on the right of this slide that Python, JavaScript, and R are supported as languages, and some common package management and custom repository tools can be used with the platform. At the downstream end of your pipelines is looking at your data, visualization and dashboards, looking at your results, data and results. You can use the UI designer of the AI suite. Again, Jupyter notebooks. For those of you familiar with Jupyter notebooks, there are many visualization utilities there. And Ex Machina will also provide its own features of data and ML results visualization. So this slide continues to enumerate some examples of what we've talked about here. And so we'd really like folks to think about how this might work for your research program and how to integrate it. There, again, Jupyter notebooks, the data tooling, the ML training, visualization, and so on. And to help you sort of put that picture together, we're going to have one follow-on webinar of yet another tool, the C3 AI Ex Machina, for development, scaling, and application of AI insights without writing code. That's a week from today. And we're also going to hold a set of weekly office hours starting that same day as the next webinar. And these are just open Zoom sessions where you're invited to just come in and chat with us, with the DTI team. And you can explain to us, say, a bit about your research computing landscape, and we can talk about how you might use these technologies so that you can incorporate that into your proposal. We're also happy to talk at that time about the possibility of bringing a DTI staff person into your team, so to speak, for your DTI work. Also on the slide, you can see the email contact for direct questions about anything about the research, the application procedure, about the platform and tools and other computing resources. There's a reminder link for the call for proposals itself. And we also have a training wiki that we develop and maintain. It's there at that final link on this page. You can get a glimpse into what it's like to get to know the platform. So I'd like to open it up for question and answers. I see, I'm going to stop my screen share here and move over to Q&A. So I see a question. What about Earth observation data? I don't fully understand the question. I don't know if Stefano, if you're asking about where to get the data or how to use it in the platform. I want to give you opportunity to write a follow-up there. I do see some more questions. What level of application details in the DTI team is the DTI looking for in the proposal, and can I access the IDS at this moment? So the quick answer to number 2 is that we don't have a way for you to access the IDS at this moment. Again, we invite you to come to our office hours, and we can look together with you at what these options are. So the level of application detail, I wonder if some of my colleagues might want to open their mics and chime in. So and again, this is something we can help you explore. We appreciate that. I think behind this question is can be you're trying to learn about the platform through these webinars while you're trying to integrate it into your proposal. So we understand that that's tricky, and we can maybe have some hands-on time together in the office hours. And I would use the proposals prompts itself as a guideline. Eric, I see your video appearing.
Well, I'm floating ahead here.
Yeah.
Can you hear me okay?
Yes, I can.
Okay. So I think, there's no specific answer, I think, for this question about the level of detail, especially since, as Greg pointed out, you're not going to have experience using the platforms going in. So there's going to be some, I don't know if I want to call it guesses, but basically what we're trying to do here is give you an idea of what it can do, the kinds of things that it can do, the kinds of things that qualify as using the software, the suites, and you can kind of pick and choose. I guess if it were me, I would focus on the current technical challenges that you might have. Now, if you've got something already, a pipeline, and you're just really concerned about scaling it up, that would be an area I think where you would want to kind of emphasize in terms of detail. If you're really just getting started and you've got a bunch of data and you don't know really much about ML and AI, and you really want to kind of explore how that might be used for your data, I think that's another way that you could sort of express, detail and, mention some of the things that we were talking about that are associated with that. There's plenty of other ways of data integration kind of things, maybe the visualization piece, maybe it's about, I think there's many ways, but I think you should sort of look to what you've done so far and what the current challenges are to really motivate that detail.
Thanks, Eric. And I see another question. Do we need to win an award to use the platform, or can we start familiarizing ourselves pre-award? So our best pathways for you to familiarize yourself is through these webinars, office hours, and the documentation that we do have up. We appreciate that this is not the same as hands-on, but there are some on our wiki at the link provided in the screen, and is our set of training materials, as well as some videos that walk through some operations on the platform. So we'd like to invite you to take a look at those. Oh, and I see another question.
Hey, Greg, maybe I can say something about this.
Oh, yeah,
question,
please, Matt.
About the Earth observation data. So I think bespoke data sets are typically not out of the box supported on C3. And, Armand, correct me if I'm wrong. It sounds like this is probably image-based data, or maybe image-like data. Maybe it's not image. Maybe your features aren't images, but like, I don't know, infrared or something like that. Usually this will require the custom creation of some sort of type. Armand talked a bit about types. You have to create an ingestion pipeline, basically. And obviously, we're here to help with that process. So, and whenever you're, so folks who are curious about this, if you have a custom data set, and many, I would even say most data sets scientists are used to working with would be considered bespoke in this case. You'd have to define some method of importing the data, but you don't necessarily have to import the data directly onto the platform. Greg had a great slide showing lists of possible ways you can use the platform. You don't have to necessarily input the data into a C3 type. You can, as Armand mentioned, you can host a model in the platform, and then maybe you define a method which receives an image and then runs your model on that image, right? And then you have a REST-enabled machine learning model. So there are many other ways than just like, if bringing all your stuff onto the C3 platform maybe is somewhat daunting, there are other very useful ways you can use a platform. So I hope that provides a high-level description. Oh, and I see Nicola has another question about platform interaction with other components. Like, okay, Box. I don't think it does. Armand, do you know if it works with Box directly?
I believe we can connect with Box via like a REST connector.
Okay, yeah. So it's through some external like interface. It's not like you have a natively supported C3 type that goes directly to Box, right?
I don't believe we have one for Box.
I believe Box, it's been a while since I've looked at it and used it, but I believe Box does have an API that you can grant access. And which would mean that the code, writing the code to make a connector would be the difference, I believe, and then in that case. Our studio, Armand, could I toss that your way? So I know ours supported by the platform, but our studio itself?
Yeah, so we can actually support like a local RStudio instance. So it's really quick to get set up, but you can actually run your local RStudio and connect over to the platform, and then be able to interact with all of the data you might have pulled in, or maybe some of your ML models. But yeah, we can use even RStudio on your machine to connect over to the platform. And we have the I'm not sure if it's called notebooks in R, but we do have a notebook that's set up to be able to do that. That would be available.
Okay, thanks. And I'm gonna continue to draw attention to a couple more questions and send them probably to Armand and Matt. I'm more of an ops person rather than the ML AI person. So I see a question: can the platform be used for? My screen is moving. Can the platform be used for training an RL agent which needs to interact with the simulator? RL being reinforcement learning. Maybe Matt or Armand.
Well, I can give you my impression is that this would be somewhat difficult. Armand, do you know of internally to C3 people who've done reinforcement learning?
We definitely have data scientists that have done this, but so I'm not a data scientist either. So this would be maybe something that I'd be able to follow up with. In this case, if it's connecting with a simulator, it would depend on like how an external application would have to interact with the simulator. So there might be a way to bring that in. That would require a little bit more of building out that connector, but it would depend on the simulator as well.
Thanks. And we have another question that, and this might be for Armand or maybe for Matt. To follow up on Stefano's question, say we have custom file types, netcdf, for example, that can be read with Python libraries available via Conda. is a new type needed in order to read these files into the C3 suite on the fly, do some analysis, including machine learning on them within C3, and get the results within C3?
Hey, so this is Matt. It sort of depends on the approach you want to take. Like I mentioned, there are different angles you can take to it. You can do the, try and integrate everything fully into C3. This comes with challenges. C3 types are really more akin to sort of database bits with like extra powers, you might say. They're like, it's like a database, almost like a database definition with like methods attached to it. But the cool thing about C3 is you can define arbitrary Python methods, and those arbitrary Python methods can, they're supported with Conda environments. So if you, for example, need netcdf that is available on Conda, you can define an environment that's suited for your method, and then your method might as an argument pass in like a netcdf file. So the platform is capable of storing netcdf files, through either on the Azure blob or locally on the container. So you basically can build a Python method which accepts a file type, you might say, then loads into a Python environment, grabs all the necessary libraries it needs, does the work it needs, and then produces some output. So in this way, the netcdf stuff is not like on the C3 proper platform, you might say. It's sort of in the Python environment, but the C3 AI environment proper is sort of interfacing with the Python environment. So I hope that does answer a little bit. Yeah, so you don't have to do everything like, specific things like netcdf, a lot of stuff is not necessarily going to fit well into a database style storage, but you can still do things inside Python methods and do stuff like processing input, send to CDF files, process that data through Python methods, and then store results into a table of some sort, which would be represented with a type, as an example. Right. This is just one example. There are other ways we can handle this. We'd have to know a little more about your problem to answer.
Thanks, Matt.
I don't know if Armand has more he wants to say.
Yeah, no, it's exactly what you said, Matt. There are a lot of ways to deal with it. So obviously, with regards to those file types, it wouldn't make sense to use the canonical transform way of being able to pull in data. But the ML Studio Jupyter service, it's just like a regular Jupyter notebook. So you can upload files directly onto the Jupyter service and access them as if it was local, like on your local machine. And likewise, you can configure your Jupyter instance to have the libraries you need and then be able to read the files. And it would be up to you at that point if you want to organize it in a data frame, and you actually train that data on ML pipelines. It'll just be the data won't exist in like, the data store. It'll be like on a file store. But you can actually then pull that data, do some manipulation within your Jupyter notebook and pass it to an ML pipeline. So because of the flexibility on the platform, it doesn't matter that if that data is stored onto a type, but if it's in the file store, you can read it into the Jupyter service and still do your training on it using the rest of the available features on the platform.
Cool. Thanks, Armand. We have a few more questions. Here's one. So in terms of expressing our research formulation, we just need to hint towards how C3 AI may help our research? Or do we need to specify the very specifics of the platform that we will be using? So this is new for this round of proposals that we're requiring this to be shown in the proposal. I think it's safe to say that we're looking for something stronger than a hint. So some, I would say, clarity of intention. These are the aspects of the technologies that we would like to use for this work, for example. And if others, I don't know if Eric or others have some other refinements on that, but yeah.
Yeah, I think you're right, Craig. I don't think a hint is probably the right level, but obviously, people can't describe what they don't fully understand. So I think that's where these office hours can be really helpful if you want to sort of ask questions, specific questions about how certain technologies might be used for certain things, I think we can, help you out in filling out some of that information.
Super. Thank you. Hope that answers the question. Another question, do you or the reviewers of our proposals expect some demonstration of leveraging C3 AI Suite, for example, creating some initial model, results, et cetera, in the proposal? Well, if I'm understanding the question, and I think it's pretty clear, I think that the easy answer is, since you only can use these technologies after the award, I think you simply don't have access to actually demonstrate use. So the exercise is to take a look at what we're presenting in these webinars, chat with us in office hours, and also consult the wiki to help you understand how you might leverage the suite. And we have another question. I would like to do ML on data from computational fluid dynamics models, both data-driven and physics-informed, i.e. not exclusively in a black box approach. Some of the simulations are with commercial software. Some we may be able to substitute with open source software or codes. Can we install open source partial differential equation solvers like OpenForm, Phoenix, et cetera, finite volume, finite element software on C3? Thank you. So Armand, can you talk about executing other software, maybe licensed software or open source software, and integrating that with the platform?
Yeah, so at least with the commercial software, it definitely wouldn't be hosted in terms of being on the platform. Typically, if there is a commercial library and all of that, it would be running in its own service and that, and of which, as part of the DTI, there is access to the Azure resources, which, Greg, you'll be able to help. So depending on what's, the ability of that software to be installed as maybe a, running as a server of some kind that can then other applications can interact with. That'd be one way between the commercial software and the platform interacting with each other, but it would not be installed on the platform itself. With regards to open source technologies, so if it's Python, JavaScript, or even Java-based libraries, those would be able to be installed on the platform, even if it's actually also like R libraries. But that would be kind of the scope with regards to the type of libraries we'd actually be able to have on the platform, and then you'd be able to then work with. So I'm not sure if OpenFOAM, I think, is maybe, I believe it to be a C++ based library. So I don't believe that would be able to be installed on the platform. But if there was any library that's in Java, JavaScript, R, or Python exclusively, then those would be able to be installed on the platform.
Thanks, Armand. And yes, to reinforce that, awardees will have access to the full range of Azure cloud resources. And so if there's a way we can deploy something like this alongside the platform and have them interface, that's a pathway we can follow for awardees. We're at just moments away from the end of our hour, and I don't see any additional questions. I've put up on my shared screen this reminder about additional sessions. Those are also available, links to those through the call for proposal site. So with that, I'd like to thank everyone for their participation and the nice set of questions. And feel free to send additional thoughts, questions to that proposals address. Those will get directed to us if they're technical. And we will see you at the next webinar and at office hours. Thanks, everyone.
Greg, I think you shared the wrong screen. It's your Zoom window. So if you
It's
just
my
want to
Zoom
flash
window
for the end of this video, yeah. It's your Zoom the desktop with Zoom.
I sure did, didn't I? Here, this is the one I'd intended to share. Does that look better? Thank you very much.
Much better, thank you.
Okay.
I think we can leave this on for a minute for the end of the video for the recording, and then
that's great. Well, it's now great. Thank you very much, Matt. Okay, thanks everyone.